All right, hopefully you've tried these questions, your last official practice questions, and see how you did with them. All right, deck of cards, just in case any of you are non-card players. In a deck of cards, there are 52 cards. 26 are black and 26 are red. So that's just kind of if you need to, and then the deck of cards are here that you can take a look at them to help you answer the questions. All right, now question 1 says, how many different 5-card hands are there in poker? All right, so let's just think about this. In a 5-card hand, when you're putting the cards in your hand, does the order matter? It doesn't matter what order they are in my hand. I might put them in an order that I want them to be in so I can see them nice, you know, maybe win some money, but it doesn't actually, the order of the cards in my hand does not matter. Okay, so in this case, let's just remember that order does not matter. Okay, and anytime that order does not matter, you're always going to want to use combinations. You can't use the fundamental counting principle and you can't use permutations. You have to use combinations. Okay, so permutations, order matters, pom-pom, combinations, it doesn't. So let's think about n. So n is the total number that I have to choose from. There's 52 cards in a deck. How many am I getting? My hand are 5, so we're going to write that as 52. I'm choosing 5 of them, and then you're just going to try that on your graphing calculator, and this is a lot of possibilities. So there's 2,598,960. Okay, so take a look at the second one. Second one says, how many different 3-card hands can be dealt from a deck of 52 cards? Once again, so 3 cards in my hand, order is not important. Just the 3 cards I have in my hand are important. So we're going to use combinations here because order does not matter. Okay, so I have a total of n is equal to 52 cards. I have r is equal to 3 because I physically want 3 of them in my hand. Okay, and then so I'm using combinations. So in combinations, you cannot use the fundamental counting principle or draw your little space positions. Okay, so you're going to do 52, choose 3, and that is going to give you 22,110. Or sorry, 22,100, which is why you can see that it's hard to win, you know, when you're playing all these casino games because there are so many different possibilities. All right, so a general manager of a fast food restaurant chain must select 6 restaurants for a promotional program. How many different possible ways can this selection be done? This is missing an important piece of information, which I'm going to add for you here. You might be wondering. Okay, so there is a total of 8 total restaurants. All right, so there's a total of 8 restaurants. And in those 8 restaurants, so we're choosing 6 of them. So there's actually, in this case, same thing. So notice how it says they're selecting 6 restaurants for a promotional program. We don't care what order they're selected in. It's just the 6 restaurants are going to be in that promotional program. So since they're in that promotional program, that is going to be combinations because in this case, order does not matter. It's just the group of restaurants. So our n, how many total do we have, is 8. How many do we want to choose? R is 6. So on my calculator, I'm going to do 8, choose 6, and that is going to give me a total of 28. Okay, question 4. An English teacher must select 6 of 15 books for her students to read in the first quarter. How many groups of 6 books can be selected? Now, notice this is not saying, you know, what order can she put them in? What order does she want the students to read them in? No, it just says how many groups of 6 books. So once again, we're going to use combinations here because in this case, order does not matter. Okay, so what is your n? I have a total of 15 books. R, I'm choosing 6 of them. So 15, choose 6. You're going to do that on your graphing calculator to get 5,005. Okay, so, this one's a little bit trickier. Let's see how we do here. From a group of 10 men and 12 women, how many committees of 5 men and 6 women can be formed? Now, this is actually two separate problems here because we're forming a group of 5 men and a group of 6 women. Now, think about this for your groups. In my groups, does it matter what order they're in? No, it doesn't matter what order they're in. All that matters is literally that I have 5 of the 10 men and 6 of the 12 women. So here, think about this. I have a group of men and I have a group of women. But since the order doesn't matter, I'm going to use permutations. So for my men, I know I have a total of 10 men. I want to choose 5 of them, so 10 combination 5. I'm going to multiply that by the number of possibilities for the women. So the women, there is a total of 12 to choose from. So I want 6 of them, so 12 choose 6. Okay, and I'm going to multiply that out together on my graphing calculator. Pretty lot of possibilities. So 232,848. All right, now back to our original problems from the very beginning of the worksheet. Okay, so I'm actually going to go back to those questions so that we can see what they had to say. All right, so let's see how you did. Assume in the state of Virginia, the license plate have 6 characters and all characters must be letters of the alphabet. The letter can be used more than once. How many possible license plates are there? Okay, this is not permutations. This is not combinations. The reason for this is because I don't have like a total group of objects and only picking some of them. This one is your fundamental counting principle because think about this. I have 6 characters and they all must be letters of the alphabet. Well, the letters of my alphabet, how many do I have to choose from? Well, on my first one, there's 26 letters in my alphabet. Second one, 26. Because it doesn't say you can't repeat them. So I can use any letter of the alphabet in any of the 6 positions. Okay, so it's going to be 26 to the 6th power. Okay, all right, so starting pitchers. There are 4 starting pitchers at McLean High School. The coach is deciding the order in which they will pitch in the rotation. Okay, so how many possible orders are there? There's actually a couple different ways to do this. Number 1, there are 4 positions. 1, 2, 3, 4. Okay, they're using all 4. So I can use pitcher 1. I can use I'm using all 4 pitchers in all 4 positions. So in position 1, I can choose any of the 4. In position 2, I've already used 1, and I've used 2 of them, and then I only have 1 person left, okay? And that's going to give me a total of 24. Now, in this case, order matters. So remember, permutation order matters. So you can think of this as n is equal to 4. There are a total of 4 pitchers. How many positions? 4 positions. So 4p4 also gives you 24. Or since you have 4 players in 4 positions, you can also use 4 factorial. So many ways to do this one. Okay, so last one says Michelle must select 5 friends from her math class of 25 students to attend a dinner party, and how many ways can she choose whom to invite? Okay, and this one, order does not matter because she's just choosing 5 friends from her math class. So this is combinations where n is 25. Okay, there's 25 friends. She's only choosing 5 of them. So 25 combination 5. Okay, and just as a refresher on your graphing calculator, you're going to type in 25 math over probability. I'm just going to go ahead and do it with you. You're going to go to 25. You're going to go to math. You're going to go over to probability. In this case, we're doing combinations, and then you're going to hit 5 and enter. So 53,130. That is a lot. All right, if you have any questions, please reach out.